friends, how are you? I hope you all are well. A new day, a new beginning. Today in this video, I am going to discuss with you about Coulomb's law, which is one of the important concept of electric charges and field. This Coulomb's law is also called Coulomb's law of electrostatics, or I can say Coulomb's law in electric force also we can say. So let us start. So before starting, one thing I would like to say, children, don't forget to share this video with your friends. At the same time, don't forget to comment on it. Your sharing can help numbers of children to gain the benefit of this channel, and your comment can make me stronger and stronger from day to day to give better and better videos. Okay, let us start from Coulomb's law. So, what is this Coulomb law? Now listen carefully. I am telling about 2-point charges. Listen carefully. What do we mean by point charge? Point charge. Point charge in the sense, if the effect of force of the charge determined from a place which distance is far more in comparison with the size of the charge, then the charge we say point charge. That means, for example, sun is very big, but whenever we are estimating its force from a large distance, in that case that sun also considered as a point charge. So whatever the charge may be, if it is very less in comparison with the distance from where we are trying to find its effect, then that charge is said to be point charge. So now let us see Q1 and Q2 are 2-point charges. For example, both are positive charge. What will happen? Definitely they will repel. They will repel each other, no doubt. Similarly, if both are negative charges, they will also repel. Suppose the distance between them is r. If one is positive charge, one is negative charge, so definitely they will attract. But in all these cases, we found there is a force. This is a point charge. A force is exerted by this charge. Here also another point charge. Here also one force is there surrounding these charged particles, no doubt at all. These two charges are similar charges, that's why their direction is like this. Here also similar charges, that's why direction is like that. Here is the opposite charges, that's why their direction is towards each other. This is also attracting. One is positive charge, one is negative charge. So suppose here is the force F, here is also force F. I am telling about the magnitude of the force. I am telling about the magnitude of the force. In fact, the direction we know like this. Here also like this, here is like this. But two two charges. I am not telling both are the same strength. It may be different, does not matter. How much force will act on this charge by this charge particle? Same force will act on this charge particle by this charge particle. That's why both places I have taken the force F. I know that force is a vector quantity, but I am discussing only about the magnitude. That means I want to say that Coulomb's law helps to calculate the force between 2 point charges when they are at rest, because our topic is related with the electrostatics. So we are discussing only about the charge particles at rest. So I can say that this law helps us to calculate the force of attraction or repulsion between 2 point charges when they are at rest. So it is better at first I shall write what is Coulomb's law. The force of attraction or repulsion between 2 point charges at rest is directly proportional to the product of the charges between them. Directly proportional to the product of the charges between them and inversely proportional to the square of the distance between them and the force act along the line joining the two charges. I have written that the force of attraction or repulsion between 2 point charges at rest, I can say stationary charges, is directly proportional to the product of the charges between them and inversely proportional to the square of the distance between them, and the force acts along the line joining the 2 point charges. This is the statement of Coulomb's law. In fact, Coulomb observed the force between the two charges. This is Charles Augustin de Coulomb. The complete name is Charles Augustin de Coulomb. He observed, he measured the force between two charges with the help of torsion balance, which is a sensitive balance used to measure the force. After that, after his observation, he proposed his law. So according to his law, So these are the 2 point charges. This is Q1, this is Q2. Both are like charges I have taken. So the distance between them is R. Okay. Now, how much force acting on this charge? That is directly proportional to this Q1. That means if the charge will be double, force also will be double. If the charge will be 3 times, the force also will be 3 times. The same force acting here also. That means that force is also directly proportional to Q2. Here the charge increase, force increase. Charge double, force also double. Charge becomes triple, force also triple. That means force is directly proportional to charge. So I can combine, I can write that force is directly proportional to, so I can say that force is directly proportional to Q1, Q2 according to Coulomb's law, or we say inverse square law. So force is directly proportional to product of their charges, and force is inversely proportional to square of the distance between them. That means you see that if this distance become double, then this force will be 1/4. If the distance become triple, the force will become 1/9, like this. So force is inversely proportional to square of the distance between them. If I combine these two equations, then I shall get that F proportional to Q1 Q2 upon R square. If I remove this proportionality symbol and I use the equality, then I shall use it F equal to K Q1 Q2 upon R square, where K is a constant of proportionality. It is called electrostatic force constant. K is electrostatic force constant, or you can say it is Coulomb's constant. So F equal to K into Q1 Q2 divided by R square, where K is a constant of proportionality. It is called the Coulomb's constant, and this value of K depends upon two factors. One factor is the medium between the two charges. What is that? One is the medium between two charges. This is one of the factor which decides the value of K. Another one is the system of units. System of units used to measure Q1, Q2, R, F, etc. That means the value of K depends upon two factors. One is the medium between the 2 point charges. Second one is the system of units what we are going to use. Suppose it is the free space, then I can say this is 1 upon 4 pi epsilon naught Q1 Q2 upon R square. This epsilon naught is called permittivity in free space, or I can say absolute permittivity. Absolute permittivity, or you can say it is permittivity in free space. Permittivity in free space, 1 upon 4 pi epsilon naught Q1 Q2 divided by R square. its value is epsilon naught. Its value is 8.9898 into 10 to the power 9 Newton. Approximately I can say 9 into, I can say it is 9 into 10 to the power 9 Newton. This is the value of epsilon naught, or we say permittivity in free space. So what about the unity of a K? See here, in this equation the unity of a force is Newton. So there must be a Newton with this. Okay, so there must be a Newton with this. What about this charge? The unit of charge in SI system is Coulomb. So I can say that there must be C to the power minus 2. Why? Here Coulomb into Coulomb, Coulomb square. To counter that Coulomb square, I have to take inverse of Coulomb square. At the same time, to counter this R square, meter square, 1 by R square, I have to use the M square. So I can say that the unit of K is Newton meter square per Coulomb square. Newton meter square per Coulomb square. This is the, if I use this one, then definitely this one will be Newton, because here Coulomb square, that's why written C to the minus 2. Here M to the minus 2, that's why taken meters. That means the unit of K is Newton meter square per Coulomb square. So what about the unit of charge? Already you know that unit of charge in SI system is Coulomb. Then what is the Coulomb? 1 Coulomb is the amount of charge which repel similar charges. So I can say that 1 Coulomb is the amount of charge which repels similar charge with a force of 9 into 10 to the power 9 Newton when the two charges are 1 meter apart. That means if this is 1 and both are like charges, similar charges, I have written 1 Coulomb is the amount of charge which repels similar charge with a force of 9 into 10 to the 9 Newton when the two charges are 1 meter apart. So the SI unit of a charge is Coulomb. What about the CGS unit? Its CGS unit is start Coulomb. Okay, so we got F equal to K into Q1 Q2 by R square. In SI system we got 1 divided by 4 pi epsilon naught Q1 Q2 upon R square. So the unit of K we got Newton meter square per Coulomb square. So what about the unit of this permittivity? So here it is the numerator, here it is the denominator. Definitely its unit will be reversed. It will be Coulomb square per Newton per meter square. This is the unit of epsilon naught. Here it is the numerator, here it is the denominator. So I have taken its reciprocal. So here minus 2 I have taken. This is plus 2, plus 1, minus 1. Here the plus 2 I have taken minus 2. That means its unit is Coulomb square per Newton per meter square. So this is about the Coulomb's inverse square law or Coulomb's law for electrostatics. So we'll see its vector form. Coulomb's law in vector form. See, here 2-point charges are there. Suppose we have taken the like charges. So definitely there will be a repulsion between them. I have taken earlier also this distance is r. Now we will consider its vector form. So in this case, I am writing F12. That means force acting on charge Q1 due to charge Q2. This side I am using F21. That means force acting on the charge Q2 due to charge Q1. Now I shall take this unit vector. That means the distance from charge Q1 to the charge Q2. And this one I shall take R21. So this is R12, this is R21. Distance from Q1 to Q2, distance from Q2 to Q1. So you know this is the unit vector. So this unit vector, you can say it has only direction because its magnitude is unit 1. So R21 I can write that. Okay. So what is the vector form of Coulomb's law? So in vector form, Coulomb's law F12 is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square R21. Similarly, I can write that F21 is equal to 1 upon 4 pi epsilon naught Q1 Q2 R square R12. So I said that this R12 R21 are the unit vector. It has only direction, its magnitude is only 1. So this is the vector form of the Coulomb's law. So here F12 represents force on charge Q1 due to Q2. F1 represents force on charge Q2 due to charge on Q1. So what are the importance of a vector form? From vector form, what we are getting? So importance of a vector form. Importance of vector form. We got that or it implies that means both charges at rest, they are applying equal and opposite forces on each other. Equal and opposite forces, both forces are acting. See that these two charges, suppose this is the 5 Coulomb charge, this is the 10 Coulomb. No matter how much force acting on it by this one, same force applied on it by this on it also. So how much charge does not matter, both apply equal force. That means it satisfies the Newton's third law. It satisfies the Newton's third law of motion. This is one point. Second point is that since these forces are acting along the line, so we can say it is a central force. So these are the importance of expression of the Coulomb's law in vector form. But there is some limitations are there. What are the limitations? This force must act between distance of 10 to the power minus 15 meter to 10 to the power 18 meter. Listen carefully. The force must act between 10 to the power minus 15 meter to 10 to the power 18 meters. Okay? If it is less than this nuclear distance, this force will not be effective. So there is a limitations. So first limitation is that charges at rest. First point is that the charges must be at rest. Second point is that it must be point charge. I said that if the amount of charge very less in comparison with the distance, then the charge is considered as point charge. So third restriction limitation, the distance must be greater than 10 to the power minus 15 meter. If it less than 10 to the minus 15 meter, what will happen? See that when the two charges are there, here two types of forces are there. One is the gravitational force, second one is the electrostatic force. If the distance less than 10 to the power minus 15 meter, then nuclear force then the nuclear force is dominates over the electrostatic force. That's why the distance should be greater than 10 to the power minus 15 meter. So these are the limitations of Coulomb's inverse square law. So I hope you understood this concept thoroughly. If anything is there, you can comment on the comment box. So definitely in the next video, I shall try to explain the facts. So until the next video, bye. Thank you.